For thousands of years, humanity was a species confined to the shore of a vast dark ocean. We stood on the surface of our small, rocky planet, looking up at the twinkling lights of the night sky, wondering what they were, how far away they stood, and if anyone was looking back. For most of our history, our only tools were our eyes and our imagination. We built myths around the constellations and mapped the wandering paths of the planets, but the true nature of the cosmos remained a locked vault. Then, 4 centuries ago, we built a key. We learned to bend light with glass, and for the first time, the universe began to come into focus. Today, we are no longer just observers. We are explorers. We have sent our eyes to the deepest reaches of space and our robotic emissaries to the surfaces of alien worlds. We have traded the campfire for the telescope and the sailing ship for the space probe. Welcome to the story of how we see the unseen, how we explore space through telescopes and probes. The journey began in 1609, when Galileo Galilei pointed a primitive tube of glass toward the moon. What he saw shattered the ancient world's understanding of the heavens. He saw craters on the moon, phases of Venus, and moons orbiting Jupiter. He proved that the heavens were not perfect and unchanging, but a place of geography and motion. Since that moment, the history of astronomy has been a race to build bigger and better eyes. But we quickly ran into a major problem: our own atmosphere. To us, the air is life-giving and transparent, but to a telescope, it is a thick, turbulent soup that blurs light and blocks entire spectrums of radiation. To truly see the stars, we had to leave the Earth behind. In 1990, we did exactly that with the launch of the Hubble Space Telescope. Perched high above the distortion of the atmosphere, Hubble transformed our understanding of the universe. It gave us the deep field images, showing us thousands of galaxies in a patch of sky no bigger than a grain of sand held at arm's length. It helped us calculate the age of the universe and showed us the violent beauty of nebulae and the death of stars. Hubble became humanity's most famous eye, a cultural icon that brought the majesty of the cosmos into our living rooms. But even Hubble had its limits. It saw primarily invisible light, the same light our eyes see. To peer deeper into the past, we needed a different kind of vision. Enter the James Webb Space Telescope, or JWST. Launched in late 2021, the Webb is not just a successor to Hubble. It is a completely different kind of machine. While Hubble sits in low Earth orbit, Webb is parked 1 million miles away at a stable point called L2. It is designed to see in infrared, a type of light that can pierce through thick clouds of cosmic dust and reveal the hidden nurseries where stars and planets are born. Because light from the very first stars has been stretched by the expansion of the universe over billions of years, it has shifted into the infrared spectrum. This makes the Webb a literal time machine. It is currently capturing light that began its journey over 13.5 billion years ago, just a heartbeat after the Big Bang. With its massive gold-plated mirrors, Webb is showing us the cosmic dawn, the moment when the first light broke the darkness of the early universe. But telescopes aren't just about mirrors and light. We have built eyes that see the invisible. Radio telescopes, like the massive ALMA array in the Atacama Desert or the now legendary Arecibo, listen to the long wavelength whispers of the cosmos. They see the cold gas where galaxies form and the high-energy jets of black holes. We have X-ray telescopes like Chandra that see the 10 million degree gas of exploding stars, and gamma-ray telescopes like Fermi that witness the most violent events in the universe. By combining these different colors of light, we create a multi-layered map of reality. We are no longer just seeing the universe. We are feeling its pulse across every frequency of the electromagnetic spectrum. As powerful as telescopes are, they are still just remote observers. They are like looking at a distant island through binoculars. To truly understand a place, you have to go there. You have to touch the soil, taste the atmosphere, and measure the magnetic fields. This is why we build space probes, our mechanical scouts that travel where no human can yet follow. These are the probes of discovery, and their journeys are among the greatest feats of engineering in human history. The gold standard for these missions is Voyager 1 and 2. Launched in 1977, these two spacecraft performed a grand tour of the outer planets, giving us our first close-up looks at Jupiter's Great Red Spot, Saturn's rings, and the icy blue worlds of Uranus and Neptune. They transformed these distant points of light into real, complex worlds with volcanoes, moons, and storms. Today, more than 45 years later, the Voyagers are the most distant human-made objects in existence. They have crossed the heliopause, the boundary where the sun's influence ends, and have entered the vast, silent realm of interstellar space. They carry the golden record, a message from Earth to any intelligence that might find them millions of years from now. They are our first interstellar ambassadors, sailing forever into the dark. While the Voyagers were flyby missions, we have since learned to stay a while. We have sent orbiters like Cassini, which spent 13 years at Saturn, dropping a probe onto the surface of its moon Titan and discovering plumes of water erupting from the moon Enceladus. We sent Galileo to Jupiter and Juno, which is currently diving through Jupiter's radiation belts to understand its deep interior. These missions aren't just taking pictures. They are sophisticated laboratories. They carry mass spectrometers, magnetometers, and dust counters, allowing us to perform chemistry and physics in environments that would destroy a human in seconds. Perhaps our most ambitious robotic efforts have been focused on our neighbor, Mars. We have sent a fleet of rovers, Sojourner, Spirit, Opportunity, Curiosity, and now Perseverance to the Red Planet. These are essentially robotic geologists. They don't just drive. They drill into rocks, analyze their composition, and look for the chemical signatures of ancient life. Perseverance is currently collecting samples of Martian soil that will be returned to Earth in a future mission. The first time we will ever bring pieces of another planet home for study. These rovers have taught us that Mars was once a world of rivers, lakes, and oceans. They have turned a cold, dead desert into a place with a history, a world that was once habitable and may yet hold secrets about the origin of life itself. Beyond the planets, we have sent probes to the small bodies of the solar system, the asteroids and comets that are the leftover scraps from the formation of our system. Missions like Rosetta, which landed a probe on a comet, and OSIRIS-REx, which recently returned a sample from the asteroid Bennu, are helping us understand where our water and organic molecules came from. They are teaching us that the ingredients for life were delivered to Earth from the heavens. We have even sent a probe, the Parker Solar Probe, to touch the sun, flying through the outermost layers of its atmosphere, to understand the solar wind that affects our entire technological civilization. The engineering required to make these missions possible is staggering. A space probe must be able to survive the extreme vibrations of a rocket launch, the vacuum of space, the intense radiation of the sun, and temperatures that swing hundreds of degrees. They must be able to think for themselves, as radio signals can take hours to travel from Earth to the outer planets. They have to navigate across millions of miles of empty space with a precision that would be like hitting a moving target from 1,000 miles away. When a probe like New Horizons flew past Pluto in 2015, it arrived within 90 seconds of its predicted time after a 9-year, 3 billion mile journey. That is the power of human mathematics and engineering. As we look to the future, the golden age of exploration is only accelerating. We are preparing to launch the Europa Clipper, a mission that will investigate the subsurface ocean of Jupiter's moon Europa to see if it could support life. We are planning the Dragonfly mission, a dual quadcopter that will fly through the thick atmosphere of Saturn's moon Titan. On the telescope front, we are looking toward the extremely large telescopes on the ground and successors to the Webb in space, like the Habitable Worlds Observatory, which will be designed specifically to search for signs of life in the atmospheres of Earth-like exoplanets. Why do we do this? Why do we spend billions of dollars on glass mirrors and robotic arms? We do it because we are a species of explorers. We do it because the pale blue dot we call home is just one small part of a much larger story. Every image from a telescope and every data point from a probe is a piece of a cosmic puzzle. They help us answer the big questions. Where did we come from? Are we alone? What is the fate of the universe? Telescopes and probes are the extensions of our senses. They allow us to see what our eyes cannot and go where our feet cannot tread. They have shown us that the universe is far more violent, beautiful, and complex than we ever dreamed. They have humbled us by showing us our insignificance, but they have also ennobled us by showing what our minds can achieve. We are no longer just people on a planet. We are the universe's way of knowing itself. As you look up at the stars tonight, remember that there are mechanical eyes out there, orbiting distant worlds and peering into the dawn of time. Remember that the stars are no longer just points of light, but real places, mountains of ice, oceans of methane, and clouds of glowing gas. We have broken the chains of our gravity, and through our technology, we have begun the great journey into the infinite. The ocean of space is vast, but we are no longer standing on the shore. We have set sail, and the horizon is just the beginning. Thank you for joining us on this voyage through the history and future of space exploration. From the first piece of glass held by Galileo to the gold mirrors of the Webb and the silent voyagers in the dark, our journey to understand the cosmos is a testament to the power of human curiosity. If you enjoyed this look at how we explore the stars, make sure to subscribe and hit the notification bell. We have many more worlds to visit and many more mysteries to solve together. Until next time, keep your eyes on the horizon, support the dreamers and the engineers, and remember, the stars are closer than they've ever been. Safe travels through the magnificent explored universe.